Hey everyone, welcome to the second lecture for this week on challenges from the sociology of science. Um, so what I wanted to do here is, again, sort of show how, especially what Loudon was doing at the end of our last lecture with this idea of a research program, how scientists choose what area, what research program they want to pursue rather than what they accept, how these research programs fit into a larger research tradition, how all of this leads into these questions regarding the sociology of science, where we are sort of making the shift away from what science does and into questions of what scientists do, right? Which is very sort of within the realm of sociology, rather than a lot of the theoretical concerns that we have been dealing with up to this point. So, what I want to do today is this is sort of a general overview of a few different claims regarding the sociology of science. One being that scientists, from a sociological perspective, are no different from those who work in other fields of study. Though their field of study is unique, the way that they go about making decisions, the way they go about cooperative ventures, these types of things, are not fundamentally different from any other group of people working towards um, a shared goal. Also, I want to sort of hint at some of the work going forward about how scientists might be swayed or might be affected by these types of factors having to do with both science as a profession, what Merton will talk about next Monday, and also the way that even our observations are affected by our own history and background, what we're going to get into with N.R. Hansen's uh, essay for next Wednesday, and then going forward, looking at issues of gender and race in the sciences as we sort of, finish up the semester. So this sort of, because this is like, this chapter from Godfrey Smith, it's like an introduction to the whole thing. It hits on a lot of these issues that we're going to be looking in more detail down the road. So, just as a reminder, I see everybody got most of everybody got the quiz in. Um, as a reminder, so some people had said that um, they missed a question or something went wrong. If you need to go back in and redo the quiz, you are certainly more than welcome to do so prior to the date, the deadline for the quiz. So I'll always grade, I think I said this earlier, the last attempt. I'm realizing now as I'm talking, you a reminder about this, and we don't have any more quizzes. So disregard that. But yeah, so everybody got it in. I'll have it graded. And, I want to go over that. That'll be the first thing that we do during the PowerPoint lecture on Monday. I'll go over that before we get into the Merton essay on the Matthew effect. So where are we at? Where did Loudon leave us at the end of the lecture on Monday, right? So we're left with this idea of a research program and a research tradition. Um, the various research programs that different scientists working in a discipline are investigating as a whole make up a research tradition. And remember, we can be a member of the scientific discipline's research tradition while pursuing a research program that you don't accept. So this was the idea of what I'm investigating versus what I believe to be true. And we had said Loudon was the first that really took and sort of cleaved those apart, right? We don't have to now say that my pursuit of something, my investigation of something is tied to my belief that it is or is likely to be the case. So Loudon says, I can certainly justify, for a variety of reasons, pursuing a research program that I don't accept, that I don't believe to be true. Right? He says we're always justified in pursuing that research program that is moving the fastest, that's making the most discoveries, that is, the novel approach that is evolving the quickest right now. I'm always justified in pursuing that, but not accepting the one that is working the fastest. I'm justified in accepting the research program that has the overall level of explanatory power, the one that's been the most successful over time. So I use the analogy of oncology here, right? In to use Loudon's criteria here, you would say that it always makes sense to pursue a fast-moving research program like proton therapy for oncology, for cancer treatment, or gene therapy, something like that. Something on the cutting edge, avant-garde therapy that's moving the fastest. They're making the most discoveries. But it always makes sense to accept or believe in the research program that has the overall level of success or the largest explanatory power, the one that's the most effective overall. So for cancer, that might be radiology or chemotherapy, right? So for that, it would be justified by these have been the most successful over time, right? So what this means is, I can pursue a research program that I don't believe in. We said you might do that because you want to prove it wrong, or you might be the best to do so, or on the off chance that it is, true, it would be groundbreaking, all of these types of reasons that we went over last class. So to understand how all of this works then, how you go about finding a research program to pursue, which one you believe, how you're justified in doing so, we're going to need to know a great deal, not just about science, but about scientists, right? What is it in a scientist that makes them pick one research program over another, right? Um, for Kuhn, this wouldn't have been a question because everyone follows the same paradigm. You don't have to ask that question. For Lakatos, it doesn't make sense because inherently, following a research program means to believe in it. So you don't have to say how one makes a decision. They make a decision based on what they have faith in. But for Loudon, we can have a whole lot of motivations as to which research program we pursue, which one that we follow, which one that we investigate. You have to know like what motivates scientists, why they would pick one research program over. And essentially, this is what we want to do. This is where Loudon leaves us. We want to recognize that like there are certain things that Kuhn got right in the subjectiveness of the sciences. When we move from one paradigm to another, it is really by general consensus. When we decide that our anomalies are significant enough that we reach a crisis point is really a decision of scientists. It's not some logical formula or some mathematical formula or something like Popper's, deductive reasoning. It is more of a subjective decision, right? So we want to acknowledge that he got that right. We want to make this more rigorous, right? We want to explain why scientists might decide on one hand that anomalies are significant enough to precipitate a crisis. Why one research program looks more promising than another research program. What's going on with scientists, right? So yeah, this idea of change and progress means that we need to understand scientists. We need an examination of who scientists are, what they do, what motivates them, and how they make decisions. In short, we need a sociology of science, right? We've gotten to a point where like this needs to be something that's investigated. We can't just keep going on the way that we have been here. Science runs by the decisions made by scientists. So how do scientists make decisions? And there were two ways to sort of understand the sociology of science. This old sociology of science that Godfrey Smith identifies as originating Robert Merton, who we're going to read for next week. And then in this, what he calls the strong program, that's more avant-garde, more controversial, that we'll discuss at the end of this lecture today. So yeah, with this old program, I mean, we're using sort of basic sociology to look at some of the basic beliefs shared by the scientific community. So, the things that you would do and the things that you would discuss in a sociology class as an undergraduate, looking for these norms, right? Practices and assumptions and beliefs that are shared among groups of people working in a certain area. Right, so like any other discipline, any other area of where people are working towards some shared goal, there are going to be these norms that are central to what scientists do and scientific research and how scientific decisions are made. So, what are these scientific norms? This comes from Merton. So we have 5. We'll look at 4 here. The first is this universalism, right? That we don't care who is making the claim. Rather, what concerns us is the claim itself, right? So you can't say so-and-so is from this school, so I don't trust them, or such and such has this background or this history, so they're less qualified to do this. What we're going to look at in the coming weeks is that this idea of the gender stereotypes in the sciences violate this norm of universalism, right? To say that women are less qualified in scientific research is a violation of the scientific norm. That the background, the attributes, who the person is making the claim doesn't matter. Is the claim good? Is the claim solid? Is the claim valuable? Becomes it should be what's important, right? So universalism, it means, just what it says, universal. Everyone carries equal weight. We're going to see Merton's going to challenge that next class with this idea of the Matthew effect. It's really interesting the way he does it, though. It's not like this prejudice or bias that we typically think of, but we'll get to that. It's interesting. So the first is universalism. Communism. Not political communism, but the underlying themes for both communism as a scientific norm and political communism are sort of, they come from the same place. So when we talk about communism in science, what we mean is that the discoveries, the results, the experiments of the sciences are shared and owned by everyone, right? They can be used by anyone so long as there's proper attribution, right? Einstein can't patent the theory of relativity and go to a scientific lab and say, you can't use that for your scientific theories unless you pay me, right? It isn't like copyrighting a song or an invention or a recipe or a slogan or whatever, right? So long as you properly attribute it to them, right, as citations in your work, or you explain where you got it from, so long as you don't try to plagiarize or pass it off as your own, you can use the research done by everyone to further science. For instance, our own Matt Lund, our resident philosopher of science in the philosophy department here, has done a lot of work on N.R. Hansen, the person that we'll read a week from today. He didn't have to pay, I'm pretty sure Hansen's dead, but he didn't have to pay Hansen's estate to do that, right? The work that Hansen did on observation can be shared and used by everyone. This is communism in the sciences. So long as he's attributed to it and say, hey, I'm getting this from Hansen. Or if someone wants to use relativity, hey, I'm getting this from Einstein's research, right? As long as there's attribution, all of these scientific discoveries and results are shared. Third scientific norm is disinterestedness, right? So what we care about is merely the pursuit of science, that scientists are not going to act out of personal gain, right? That a scientist isn't going to decide what they want to look at based on what's going to make them the most money, or decide what outcome is going to be the most favorable for them financially, right? There's disinterestedness. While they might want a certain outcome, if one is working in COVID-19 vaccination research, right? One is certainly not disinterested in that they don't care about the outcome. They certainly want their experiments and their attempts to find a vaccine to be successful. But if they're unsuccessful, they're not going to look the other way. They're disinterested in the sense that they will look at that honestly and say, well, this didn't work, despite any lost financial gain in patenting a new vaccine. And organized skepticism. This becomes really important to the sciences, right? We don't take things on faith. Anything that we do needs to be proven and also needs to be able to be reproduced. This right now, well, you see this with this chloroquine, this supposed treatment for coronavirus, right? So the president has really been pushing this. The FDA just approved this treatment of, I think it's chloroquine with a Z-Pak as azithromycin, where one could take this, and there has been some research that suggests that those who take Z-Pak and the chloroquine together it has some beneficial effects on people who have coronavirus. And the issue from this organized skepticism is that the sample size is really low. It's basically like one research study out of France where you have, I think, 20 participants, and only 6 of them were given both the Z-Pak and the chloroquine. Now, granted, 6 out of 6 recovered from coronavirus given after they were given both of those medications, but because it's such a small sample size, our organized skepticism tells us we need to do more there, right? I can't just trust that because of those 6 people that I can say without a doubt that chloroquine and Z-Pak, cure coronavirus, right? That organized skepticism tells us that we can't just take that on the faith of 6 positive results. We need to reproduce that much more. So These are sociologically the scientific norms that Merton has identified that scientists work by: universalism, communism, disinterestedness, and organized skepticism. Interestingly, if you go sort of down the rabbit hole with this idea of these norms, there's a way that Merton argues that we distinguish science from pseudoscience in much the same way. He calls this a multi-criterial definition of the sciences based on their norms of universalism, skepticism, communism, and disinterestedness. Right? And just like that, pseudoscience has their own norms: belief in authority, unrepeatable experiments, handpicked examples, unwillingness to test, disregard for refuting information, it's built-in subterfuge, explanations are abandoned without replacement, sort of the same things that Popper was talking about. So what I mean at the top here is that Popper saw there was one feature that differentiated the sciences from pseudosciences. That was falsifiability, the way that we've talked about, the way that a lot of you wrote about for your midterm essay. In contrast, Merton has a multi-feature definition of the sciences as those scientific norms, and then pseudoscience has multiple features that are different, these pseudoscientific norms. I put it on the bottom. If anybody's interested in this, this is where you get these pseudoscientific norms from this essay by Hansen. Not the Hansen that we're going to read. This is a different Hansen called "Is Anthroposophy a Science?" I have a copy of this or a link to it. If anybody's interested in reading it, shoot me an email. The short answer to the question is no. Anthroposophy is this belief going back to German Romanticism in the 19th century that one could scientifically prove the spiritual world. So no, anthroposophy is not a science. But the way that he identifies anthroposophy and the way that he defines it as not being a science is based on all of these pseudoscientific norms. It's a cool essay. Like I said, if anybody is interested in it, it's actually really hard to find a copy of it. It took me a while to dig it up. So yeah, if anybody's interested, I have a copy. Cool. Anyway, back to the scientific norms. So we have universalism, communism, disinterestedness, organized skepticism, and one more norm that guides science and scientific research is recognition. Right? Scientists are motivated by recognition. So this plays a large role in the sociology of sciences going forward. This idea that this becomes the reward system for the sciences, being recognized as the one who discovered something, being recognized as the lead researcher on a wildly successful project. That is the reward system for the sciences. So again, we're talking about recognition of being the first, right? The one to make a discovery. This is based on this idea of communism. The only really idea of ownership of the science that the sciences has is that whoever discovers something gets to name it, right? If you discover a planet, if you discover an asteroid, you get to name it whatever you want. You can name it after yourself. And this is, we identify ownership as that, right? So again, this isn't real ownership. Like if someone else wants to use it, they have to pay me for it. Right? Newtonian physics, Newton didn't get a check every time someone used it to calculate, the velocity of something or the force of something. But ownership means you have to, if you want to use my work, you have to give me credit for it. This was the idea of proper attribution that I just discussed, right? So yeah, so this is why we call it the Copernican revolution, giving credit to Copernicus. Einstein's theory of relativity, Newtonian physics, Darwinian evolution, Mendelian genetics, all of these are attributed to the person who discovered it, the recognition as being the one who made that discovery. There's two important implications for the idea that that recognition is what guides scientists. First, it acknowledges that scientists are human, right? They're motivated by very human concerns, and that this motivation can be compatible with other scientific norms. I can say I'm motivated by, I want that recognition without violating universalism, communism, disinterestedness, or organized skepticism, right? This is compatible with those other norms. But it also acknowledges that they're not just doing this out of the goodness of their heart. They want to get something out of it for themselves other than just a paycheck. They want that recognition. This is why they're making discoveries. Also, in that scientists want that recognition, recognition is a good method to motivate scientists. So think about Loudon. We talk about the allocation of scientists to different research programs. We already said you don't have to believe in one to work under it. So the question from, let's say, the leader of a research lab would be, how best do we allocate our scientists to different research programs, right? Invariably, everyone probably wants to work on the one that's the most promising, right? Like no one's gonna, if you had two different research programs in oncology, and you said research program A has a, you know, 99% chance of being true. So research program A, well, not say 99, let's say 90% chance of being successful in curing a certain type of cancer. And research program B has a 10% chance of curing cancer. Everyone's going to want to work in A, right? That's not good for science, though. I mean, think about it, right? Sure, 90% is 90%, but if no one's working in the second one, then what if that second one does turn out to be true? You've just disregarded it. Even if it's only a 10% possibility, there's a 1 in 10 chance that it might cure cancer. So you don't want to put all your eggs in one basket, so to speak, right? You want to say to some scientists, hey, don't work on that one that's the most promising. Work on this one that there's only a 10% chance that it's going to be effective. How do you justify that for scientists? How do you tell someone that their life's work is going to be something that only has a 1 in 10 chance of being successful? And no, we have this other idea that's 90%, 9 in 10 chance of being successful, but you can't work on that. How do you justify that? And the way you do that is by recognition, right? So think about it this way. Let's say we have research program A, and I think, this analogy that Loudon uses is like it's like a pie, right? And research says is A. I'm going to try to make an A on here. This is going to be awful. So that's research program A. I missed my whiteboard, by the way. And over here is research program B. Let's try this. Lovely. Right, so research program A, I'm not going to try to write 90% and 10%, but you get the idea. A is 90%, B is 10%. So what you do is you obviously put most of your scientists, you allocate them to research program A over here, right? And but you don't want to allocate all of them. So how do you motivate some to work in research program B? Well, you do it this way. You say, look, there's a ton of people working in research program A. Let's say there's 100 people working in research program A. And yeah, there's a 99% chance of it being successful. But if it is, if we think of this pie here as the recognition for a successful theory, your own slice of that pie, of that recognition, if there's 100 people working on it, is going to be real small, right? That's your portion of recognition for working in this really successful research program. So while there's a very good chance it's going to be successful, even if it is, you get very little recognition for that. Over here with research program B, let's say I only stick 10 of you on it. You can see what's going to happen here. There's not a great chance that research program B is going to be successful, but if it is, your slice of that recognition pie is much bigger, right? That's how you motivate scientists, by recognition. You say, sure, there's not as great of a chance over here, but if it was true, you're going to be like the top researcher on that. And you say, if you went with A, where there's a 90% chance that it works great, but there's also 100 scientists working on it, you're going to be a footnote on page 5. Now, what do you want to be? You want to be you want to have the less chance of being successful, but if it is, you're the lead researcher, or do you want to be the more greater chance of successful, even if it is, you're on page 5? That's how you motivate scientists. This becomes really important to Merton's work for Tuesday as well, or for Monday as well. So recognition is how we motivate scientists to work on less promising research programs. Yeah, it's sort of this currency for the sciences. And I use that term, understanding the implications of what it means to be currency. Like money, recognition has instrumental value. It's good for something, right? So what Merton will talk about is the more recognition I get, the more I can use that recognition to further my research. Maybe the more recognition I get, I have more access to to resources from my department. They're more apt to give me time in the lab or money or grants, right? I have more access to graduate students to do work. More people trust me and read me. I get published more. This is all based on recognition. Recognition is not just to show that I have done something great. It's that recognition is useful for the sciences and for scientists going forward. So it's more reason to motivate them, not just to discover that, but because you can use that recognition down the road. It's good for something. But competition for recognition, there's a threat that it undermines other scientific norms. Godfrey Smith mentions this: sabotaging experiments, plagiarism, fudging results to make them look more promising than they are. So we don't spend as much time here on the strong program. It's really interesting. One of the reasons is that it's some of it gets a bit theoretical for an introductory class. The two books that we talk about, Laboratory Life and Leviathan and the Air Pump, I would love, and I think a lot of you would find interesting more of an upper level class where we dealt with them in detail. Fortunately, we don't have the time, and given that this is a survey class of like 100 years of philosophy of science, we can't read a whole books. We sort of did with Kuhn, both because his is super important and because it was relatively a quick read. The whole thing is only about 150 pages. Um, Leviathan and the Air Pump is over 300 pages long. It's just not something that we could do in the class. So, but this strong program, is going to argue, first of all, what we've already said, that scientific disciplines are based on are groups of people composed of, or sorry, are groups composed of people who aren't fundamentally different from other groups that are, committed to collective goals. So Godfrey Smith says this. This is on 126. He says, let's see here. Scientists are not some special breed of pure, disinterested thinkers who pay attention to nothing but data and logic. People of all kinds live in communities that have socially established norms for regulating belief, norms for supporting claims, for handling disagreements, for working out who will be listened to and who will be ignored. These norms will often be subtle habits rather than explicitly stated rules. Scientists are people who work in an unusual kind of local community. This community is characterized by high prestige, lengthy training and initiation, notoriously bad fashion choices, and expensive toys. But according to sociologists, it is still a community in which beliefs are established and defended by local norms that are human creations, maintained by social interaction. So, scientists then are no different from agents of any particular group. They might differ in the way in what binds them together, these scientific norms that we discussed, but they're really no different when it comes to why and how they're bound together and how they agree or disagree and how they create those norms is the way that they come about those norms. Though the norms themselves might differ, their methods of interaction and methods of agreement don't differ from any other group that is working toward a collective goal. Whether that's a sports team, whether that's an orchestra, whether that's a business, whether that's a class, right? The underlying process is the same, even if the results are different. So even if one isn't swayed by these external factors of recognition and things like that, sociology of science, in that these are humans pursuing very human endeavors, this gives us good reason to suspect that scientists might not be as pure or objective as we believe them to be. This we'll get into less with Merton on Monday and more with Hansen on Wednesday. So, strong program. Scientists have beliefs just like any other group, and they come to these beliefs in similar ways. Regardless of the things that Popper tells us about scientists being, cowboys with Stradivariuses or whatever, right? We are, or those of us, I say we like I'm a scientist, those who work in the sciences are no different than others working in other pursuits. So, groups, any group, scientists included or scientific disciplines included, come to their conclusions based on socially established norms that are particular to that group. So we refer to these as local norms. And these local norms dictate a lot of things for any group. Godfrey Smith listed them in that last quote: how beliefs and claims are supported, how we handle disagreements, who will be taken seriously and who will be ignored. For some of you, this should already sound very familiar. It sounds very much like what's dictated by a paradigm, right? So we could probably add to that how success is measured, how terminology is used, all of these things as well. So this is where we get into these last two works, Latour and Woolgar's Laboratory Life, which is a super interesting book, and it actually is pretty readable. If anybody is interested in it, I'm sure you can find a used copy on Amazon for 25 cents. Well, maybe not now. Actually, you could probably find it now, but it would take a month to get here. But you can find them, and it's relatively, it's interesting for anyone who's interested in the sociology of science. This was the analogy I used, that Latour really treats the scientific lab like he's going into a uncontacted tribe, and he's writing down their sort of their practices and their cultural beliefs and who the dominant figures are and how they deal with disagreements and all of these things. He treats the lab sociologically, right? And Godfrey Smith describes this as this shift in thinking about the science. It ignores everything that we think of as important. So all the theoretical stuff that we've dealt with up to this point in the semester. What Latour says, if I want to figure out what science does, I'm going to look at scientists. I'm not going to look at inductive reasoning. I'm not going to look at evidence and disconfirmation and confirmation and ravens and swans and is Socrates mortal and analytic and synthetic statements. I'm going to the source. I'm going to go hide behind an office plant and look at a scientific lab. Yeah, so I mean, he really does this. Instead of looking at all the things we've discussed thus far, there's this diagram that comes from like one of the first pages of Laboratory Life. This is the diagram of on 133 from Godfrey Smith of the lab. Income, telephone, mail, energy, chemicals, animals, and out comes articles, right? So yeah, it's a contained unit or a machine. Their input is money, chemicals, paper, animals, and their output is reports, journal articles, and discoveries, right? You feed things in one side, and what comes out the other is the finished product in the form of journal articles and discoveries. So what Latour and Woolgar look at is like, well, what happens inside? What happens inside that machine? Like a laboratory isn't a machine. It's a nice metaphor, but scientists aren't inanimate components. They're not cogs and gears. Right? They don't run in a uniform way in the way that cogs and gears do. We can't explain scientists by mere physics. Right? Keeping all this hidden, all of the work that scientists do, all of the messy stuff that happens in a lab is vitally important for this traditional view of the sciences that we've worked with over the course of the semester. That scientists are disinterested cogs in some scientific machine. And this simply isn't the case, or so the Strong program claims is not the case. Yeah, this is from Godfrey Smith on 132. The key step in the process is hiding the human work in the lab, hiding the human work that turns something into a fact. Right, to make it look like it's not a human product, but just a discovery given by nature. So the implication of all this is that scientific facts are what we call socially constructed. And this is where we get a little bit off the rails as far as like for an introductory class. Not off the rails in the sense that it's not believable. I certainly think that it is. Godfrey Smith a bit less so. But for our purposes, this is why one of the reasons why we won't read, Leviathan and this idea of social constructivism. I think all of us hold to a view of what is referred to as weak social constructivism, that the way we represent reality is socially constructed. So our ideas of race and gender are obviously socially constructed. Our ideas, regarding gender and racial stereotypes are socially constructed. We give that to the world. They're not created or found in nature. Strong social constructivism is a bit different. Strong social constructivism is going to claim that like reality itself or facts, discoveries are actually socially constructed. They're not objective. And again, this is why this gets a bit further away from what we want to do here. So I'll just sort of suggest how this Leviathan and the air pump does this to sort of finish off the lecture today. Essentially, yeah, this story is the story of this debate between Boyle and Hobbes regarding the discovery of vacuums, right? So Robert Boyle, famous scientist, Hobbes, you probably know from ethics or political philosophy, writing Leviathan, which is where the name comes from, this book of a political treatise that Hobbes writes. This would have been in the 1600s. They're arguing about whether it's possible to discover vacuums. So back to the time of Aristotle, it was argued that a natural vacuum was impossible, that something would fill it, right? That you could not have an empty space, right? The nature aboard a vacuum is the quote that we've all heard, right? And the argument that Boyle discovered vacuums was challenged by Hobbes. Hobbes is going to say you didn't discover vacuums. You created a condition where you made a vacuum using an air pump, right? But remember, Aristotle said natural vacuums are impossible. So Boyle really violated the argument from Hobbes that Boyle violated one of Aristotle's premises. He didn't discover a vacuum, he created one. So in essence, like he adapted Aristotle's experiment. He reframed it to fit the discovery that he did make. So he didn't so much prove Aristotle wrong as he recreated what he was looking at, what he was looking for. Um, yeah, this is a super interesting discussion. It really has less centrally to do with what we're going to look at going forward. But what I did want to get from this strong program is this idea that what we see, what we observe, the ways that we observe it, what we draw from it, all of these things are really affected by our own history, our own background, who we are, what we bring to an observation. That we are not neutral observers, that our own history and background, whether that's what we saw yesterday, whether that's how we grew up, whether that's our race or gender or ethnicity, all sort of frame and inform the way that we observe. A weak claim would be the way that we interpret data. A strong claim would be it affects the data itself, not just the way that we observe, but the observation itself. This is where we get into at the end of next week. What I'm going to do first is return to this old program with Merton, with this Matthew effect, to look at sociology in the sciences, specifically who gets listened to and who gets ignored, and how this affects the sciences. Then on Wednesday, we're going to look at some more extreme positions, and I say extreme not to say that they're less plausible, but to say that they're more sort of challenging to this idea of the sciences as an objective field of study, starting with Hansen, and then we move on to gender and race in the next few weeks. So, yeah, so for Monday, I'll have the quizzes graded. Um, and yeah, if anything comes up, feel free to shoot me an email and set up some time to meet. And if not, I will post another video on Monday. Everybody stay safe, wash your hands. I'll see you all then.